Okay, so today we're going to be going over angles in standard form, and we're going to be using this little diagram here that has the angle in standard form, and this is preparing us for the unit circle because the unit circle is going to be on the XY table. So you see that here we have an XY axis coordinate plane, so that's where our unit circle is going to be on, and that's where our angles in standard form are going to be on. So let's go over the notes. So the first bullet point says that an angle on the coordinate plane is in standard form when the vertex is on the origin and one ray lies on the positive x-axis. Okay, so the vertex would be right here. Whoops. This would be the vertex, right? So when the vertex is on at the origin, which it is here, and one ray is on the positive x-axis. We know that this is the positive x-axis, right? So one ray has to be there, and the vertex has to be at the origin in order for it to be in standard form. And then, so if we look at the next bullet point, it says the ray on the x-axis is called the initial side. So the red ray that I just labeled, that is called the initial side. So that's where the angle starts. Then the other ray is called the terminal side. And I'm going to label that one in blue. So this right here would be the terminal side. The next bullet point says that counterclockwise rotations result in positive angle measures. So positive angle measures. So you see this right here. This is representing a counterclockwise rotation. So that is a positive angle measure. Right, so when it moves in, when the angle opens up in that direction, it is positive. Next, clockwise rotations result in negative angle measures. So here's our initial side. So if we start there and our angle rotates in this direction, that is a negative angle measure. And then one full revolution, we know that is going to be 360 degrees, right? Because the measure of an angle or a circle is 360 degrees. So if it does one full revolution like this, that is 360 degrees. All right, so now let's practice drawing angles, and this is just estimates. It doesn't have to be 100% exact. So we're going to sketch an angle with the given measures in standard position, right? All right, so standard position, our vertex has to be here. And we have to have one ray on the positive x-axis, right? So we're just going to measure. So if you want to pause the video and draw out these measures real quick and then check, I'm going to go over them now. So number one, we have a 75-degree angle, and this right here would form a 90-degree angle, right? So we know that each thing right here, that's 90 degrees. So this is 90 degrees. This is another 90 degrees, so it's 180. This is another 90 degrees, so this is 270. And then the final other 90 degrees, that's 360 degrees, right? So we know that, since we know that right here, the y-axis, the positive y-axis is 90 degrees, we know that it has to be between the positive x-axis and the positive y-axis, right? So I'm going to estimate and say that 75 degrees is somewhere around here, right? And again, it doesn't have to be exact. And the rotation was in this direction, which is what makes it positive 75 degrees. If it was negative 75 degrees, you would want to go in this direction. All right, so number two is negative 160 degrees. So one full rotation like this would be negative 180 degrees. So I know that it has to be between these two planes right here, right? So I'm going to draw my vertex first. So my vertex is right here. Next, I'm going to draw my initial side, right? That's where we started. So now it's going to be in standard form wherever we draw our angle. And negative 160 degrees. So I'm going to estimate that it's going to be somewhere around here, right? And since the rotation was clockwise, this is a negative 160 degree angle. All right, and then 430 degrees. So first I'm going to draw my vertex. I'm going to draw my initial side. And 430 is more than 360, so we know that it's going to be more than one full rotation, right? So one full rotation like this would be 360 degrees. And then, so 430 minus 360, that leaves us with 70 degrees. So once we get back to our initial side, it's going to still rotate another 70 degrees. So I'm going to estimate that it is going to land somewhere around here, right? Again, it doesn't have to be exact, but that's an estimate. And the way that this rotates, it goes full 360 and then ends right around there. So this is about a positive 430 degree angle measure. All right, so hope that made sense. Now let's talk about radians versus degrees. So first, what radians are, I'm going to try to explain this in the simplest terms because the notes here can be a little confusing, but essentially what a radian is, it's another way to measure an angle. So in our lessons yesterday and the day before, we're given theta, right? So, and we find the angle measure in degrees based off of this right here, right? Well, radians, they measure angles in terms of, well, in radians, this is what we use to find the measure of an angle. This is called an arc, and it is the arc that our angle forms. And that's what a radian is, right? So we'll come back to this diagram when we talk about what one radian is. Okay, so here it tells us that a radian is a unit of angle measures based on arc length. So what I was just describing to you guys, one radian is defined as the measure of one radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. And then it tells us to recall that the circumference of a circle is 2 pi r. We'll come back to that. So first, let's look at this. One radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. That might not make sense to you, but I'm going to try to explain it in simplest terms. So just like I told you guys, this right here would be a radian. That's how we determine the angle measure in radians. So one radian is equal to the same length as the radius, right? So if the length of this arc is the same as your radius, then that is 1 radian. So 1 radian is the same as the radius of your circle. And this could change based off of the size of your circle, but just know that 1 radian is the same as the radius, whatever your radius is, right? In the unit circle, we're going to have a radius of 1. So the arc length would be, the 1 radian would be when the arc length has an exact measure of 1 unit. Okay. And so now let's look at this. It says, recall that the circumference of a circle is 2 times radius times pi. So 2 radius pi. All right. And the circumference, if you don't remember, is the measure of the perimeter around the circle, right? So like the whole, so they would be measure of this entire thing. That's what the diameter is, or sorry, the circumference is. All right. So we need to figure out how many radians 360 degrees is. So if 1 radian equals the radius and the measure of the circumference of a circle is 2 times radius times pi, well, radius and radian are the same thing, right? And 360 degrees is the entire circumference of the circle, right? Because that would be this angle right here, which forms the entire circumference of the circle. So since we know that the 1 radian is the same as a radius, well, a 300 and the circumference of a circle is 2 times radius times pi. That means that a 360 degree angle would be the same as 2 pi radians, right? Because we know that radius is the same as a radian. Hope that makes sense. If it doesn't make sense, please let me know. And then, all right, so we're going to write that over here. So 2 pi. So a 360 degree angle is the same as 2 pi radians. All right, and then a 180 degree angle, well, that's half of a 360 degree angle, right? So it'd be half of this. So half of 2 pi's is just 1 pi, right? So a 180 degree angle would be the same as pi radians. This is 2 pi radians. Okay. And it may be easy to remember radius and radian sound the same. And that will be helpful when you're thinking, okay, 1 radian is the same as the radius. All right, so now we're going to practice converting from degrees to radians and from radians to degrees. Okay, so if you have a degree measure, you're going to use this formula right here. So radians equals the degrees times pi radians over 180. Okay. And then if you're converting from radians, so if you're given radians and you want to find how many degrees that radian is equivalent to, you're going to do radians times 180 over pi radians. It's going to make a little more sense once we apply it. So let's go ahead and do number 4. So it says convert each measure to radians. So the formula is radians let me do a thinner pen. So radians equals the degrees times pi radians over 180. The pi radians is just gonna take on the form of the degree, so it'll make sense right now when I write this. So radians equals, so the degrees that we have is 30 degrees, right? So 30 degrees times pi radians over, well, we can just write pi instead of pi radians, so pi over 180. So the radians is going to be equal to 30 degrees times pi over 180. So you're just going to treat this as just 30, right? So that's going to be 30 pi over 180, right? And then you can simplify this further because 30 and 180 are both divisible by 30, right? So 30 divided by 30 is 1, and 180 divided by 30 is 6. So this is the same as pi over 6. All right, so let's look at 150. So again, it's going to be the degrees. So 150 degrees times pi over 180. All right, so and I don't know if it didn't make sense in the first one, but this is the same as 150 over 1, right? And when you're multiplying two fractions, you do numerator times numerator, denominator times denominator. That's how I got 30 pi over 180 in the previous one. So here we're going to get 150 pi over 180. And both of these are evenly divisible by 30 as well, right? So 150 divided by 30 is 5. So when we simplify, we get 5 pi over 6. All right, so 5 pi over 6 is what we get when we simplify 150 pi over 180. All right, so for number 6, we have negative 220 degrees. So negative 220 times pi over 180. And we get negative 220 pi over 180. And 180 and 220 are evenly, we'll have to find what they're both evenly divisible by. So let's see, 180 divided by... Oh, so they're both evenly divisible by 20. So 220 divided by 20 gives us 11 pi. And 180 divided by 20 is 9. So when we simplify, we get negative 11 pi over 9. All right, so hope that made sense. If you have any questions, please let me know. And then let's go over the last couple here. So now we're going to be converting from radians to degrees, right? So the measure, I'm going to write out the full measure. So degrees, or not the full measure, but the full equation. So degrees is equal to radians times 180 over pi radians, or we'll just say pi, right? So this is my radians, right? So 4 pi over 3 times 180 over pi is going to give us our degrees. So 4 pi times 180, so 4 times 180 is 720 pi, and 3 times pi is just 3 pi. So the pi's cancel each other out, and then I'm left with just 720 divided by 3, and that is going to be 240 degrees. So 240 degrees is the same as 4 pi over 3. All right, so negative 5 pi over 36. So we're going to multiply that. This is our radians, and we're going to multiply that by 180 over pi. So 5 times 180. 5 times 180 is 900. So we get negative 900 pi over 36 pi. The pi's cancel each other out, and we're left with negative 900 divided by 36, and that's going to give us negative 25 degrees. All right, and then number 7, so we're going to again multiply by 180 over pi. So 7 times 180 gives us 1,260 over 4 pi. 1,260 pi over 4 pi, right? The pi's cancel each other out, and then we're left with 1,260 divided by 4, which is 315 degrees. All right. So I hope this made sense. Please let me know if you have any questions on this, and I will be happy to help.